Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic sulfonation is reversible, and in deuterated acidic media, HD exchange occurs on the benzene ring. Moving on to the next step. When benzene is treated with H2SO4, it undergoes electrophilic aromatic sulfonation to give benzenesulfonic acid, C6H5SO3H. This reaction is reversible upon heating with dilute acid or water. The sulfonic acid group is removed, desulfonation. Moving on to the next step. In this problem, the reagent is 80% D2SO4 in D2O, which provides D+, deuterium ions, as the electrophile instead of H+. And for the final step, D2SO4 D2O generates D+ in solution. Benzene undergoes electrophilic aromatic substitution where D+ acts as the electrophile, replacing each ring H with D. Because the sulfonic acid acts as a leaving group in the reverse reaction, the sulfonate group temporarily activates the ring for HD exchange, but net result is replacement of all 6 H atoms on the benzene ring with D. With a large excess of D2SO4 in D2O and heating, all 6 aromatic hydrogens undergo HD exchange, yielding C6D6, benzene D6. A C6H5SO3D, this would be the sulfonation product, but the large excess of deuterated solvent and heating drives complete HD exchange rather than stopping at sulfonation. B. C6H5OD, there is no pathway for hydroxylation of benzene under these conditions. C. C6H5D, this would represent only one H replaced by D, but under large excess D2SO4 D2O with heating, all 6 hydrogens are exchanged. The use of a large excess of D2SO4 in D2O and heating ensures complete isotopic exchange of all 6 ring hydrogens, giving fully deuterated benzene, C6D6. Therefore, the correct answer is D. Therefore, the correct answer is option D.